In today's lesson, we're going to be standardizing any normal distribution. Standardizing any normal distribution. This is what we use these charts for. A production line produces bags of sugar with a mean weight of 1.01 kilograms. Notice, it's not zero. The mean is not zero. It's 1.01. And an standard deviation of 0.02. Notice, that's not 1. But we want to make this into 0 and this into 1. They give us the standard deviation, not the variance. First, find the proportion of bags that weigh less than 1.03 kilograms. Well, to do this, I have to relate 1.03 kilograms to the standard normal curve. Well, how many standard deviations above my average is 1.03? This is where I use my formula. 1.03 minus the average of 1.01, all divided by my standard deviation of 0.02. Notice they gave me as standard deviation, so I can just plug that in. Gives me 0.02 divided by 0.02, which is 1. So now I can go to my chart and look. I'm looking for less than 1 on my chart, because now I've put it into standard. I've standardized it to a standard normal distribution, and on my chart I get, if you convert this to a z-value, you get 8413. This is your z-value. This is the proportion less than 1 is 8413, or about 84%. In the second part of this same problem, we're asked to find the proportion of the bags that weigh more than 1.02 kilograms. Well, my first step is I have to relate 1.02 kilograms to my mean and using my SD by converting this normally distributed data into a standard normal curve. How do I do that? I find my z-value, which is x minus the average divided by the standard deviation. Well, my x in this case is 1.02 minus my average 1.01 divided by my standard deviation 0.02 gives me 0.05. I want to know the proportions of bags that are heavier than that. This is my area here. I want to know that. Well, if this is given on your charts, you're going to have to find the probability that z is greater than 0.5 is equal to 1 minus the probability that z is less than 0.5. Well, when you look that up on your chart, you find that this is equal to 1 minus 0.6915, which is equal to 0.3085. Okay, last one, dealing with this same problem. We are given that the average bag of sugar is 1.01 kg and it has a standard deviation of 0.02. Be careful, sometimes they give you variance. In this case, they gave us standard deviation. And that's what we want to use in our equation. Our last question asks us to find the percentage of bags that weigh between 1.00 kilograms and 1.05 kilograms. Well, first, this is normally distributed data, but it's not in the standard normal curve. So let's convert to the standard normal curve using z is equal to x minus ru divided by r sigma. So this is 1 minus 1.01 divided by 0.02 gives us negative 0.5 for our first one, 1 kilogram. 1.05 kilograms is going to be 1.05 minus our average divided by our standard deviation, which gives us 2. What's the probability between negative 0.5 and 2? Well, I want to find a sketch there. That's my red area. That's what I want to know. Which will be, luckily, it's going to be anything less than 2 minus anything less than negative 0.5, which ultimately works out to 9.9772, which is anything less than 2. How do I find less than negative 0.5? It'll be the same as 1 minus less than 0.5, which will be, we talked about that earlier. So you'd have to find out what that area is. It turns out to be 0.3085. This minus this gives us 0.6687, which is about 67%.